Hello friends, welcome to CIVILDEPTH-BD. From today, we are going to start ETABS building design series tutorial for a G+4 storied residential building. Here you can see the ground floor roof beam layout plan. This one is typical floor roof beam layout plan. From this ground floor roof beam layout plan, we have prepared grid line distances between the column. Here, for grid A, there may have some differences in column center line, but here we are considering that all columns in grid A are at the same center point. Similarly, for grid B, C, D, E, F, 1, 2, 3, 4. Okay. There may have little difference, but we are considering all the columns are at the same center point throughout any grid. Okay. Or you can assign link property in ETABS, but this is not very mandatory here. Here we will consider the center line method. Here in X direction we have A to grid number F, and in Y direction we have 1 to grid number 4. Okay, here we have also prepared a chart of ETABS steps. At first we will open a new file, we will select our desired code, we will edit grid data, then story data. Let's go to ETABS. Here I am using ETABS version 20.2. You can use any version. So let's go to File, go to New Model. Use built-in settings, region for default material, United States, concrete design code, here I am using ACI 31814, click on OK. Now go to custom grid spacing, go to edit grid data. Here you will see two options for assigning grid data. One is display grid data as ordinate and another one is display grid data as ordinate. Display grid data as spacing. If you select display grid data as ordinate, in that case you have to input values like 15 feet 10 inches for grid number A. Then for grid B you have to assign 15 feet 10 inches plus 3 feet. For grid number C, you have to assign 15 feet 10 inches plus 3 feet plus 8 feet 5 inches. That means if you select display grid data as ordinate, in that case you have to assign cumulative distances. Okay. But if you select display grid data spacing, then you can assign values as it is. In X direction, we have grids up to F, so we will add some more grids here. After D we need grid E, F. Okay, in Y direction we have 4 grids, so there is no necessity of adding any more grids in Y direction. For grid A, distance is 15 feet 10 inches, then 3 feet 8 feet 5, 2 feet 8, 15 feet 10 inches, 3 feet, 3 feet, okay, 3, not necessary to assign the feet symbol as it is already in feet. For grid C, distance is 8 feet 5 inches. Then 2 feet 8 inches, 16 feet 1 inches. Let me check again. 15 feet 10, 3 feet, 8 feet, 5 inches, 2 feet, 8 inches, 16 feet, 1 inches. After grid F, there is no more grid. So the value of grid F will be 0. Okay, the value of spacing for grid F will be 0. Now let's come to y direction. For grid 1, distance will be 16 feet, 7 inches, 3 feet, 11 feet, 10 inches, 14 feet. There is some problem in my keyboard. 7 inches, and last one will be 0. 16 feet, 7 inches, 11 feet, 10 inches, then 14 feet, 7 inches. From here you can control the size of bubble also. Suppose here I am using 40-inch bubble size. You can also modify the grid colors. Okay. Now click on OK. Go to the story dimensions, bottom story height. Here we are considering 8 feet. That means from EGL to the bottom of the footing will be 8 feet. Typical story height, here we are considering 10 feet. Number of story, we know here we have total 5 stories, but initially we will model only 2 stories. After that we can replicate the typical story to the above. Okay, so let's take number of stories as 2. Click on OK. Here you can see total 3 window. One is for Model Explorer, second one is for Plan View, third one is for 3D view. Let's go to options, then go to graphics mode. From here select standard graphics. Here in ETABS version 20.2 we have 2 types of graphics. One is standard graphics and another one is DirectX. We will select standard graphics. Let's save the file. Now we will go to step number 2. That means we will define materials like concrete and rebar. From here go to define material properties, add new material, select concrete. Here I am taking 3000 psi. Okay, for 3000 psi this value is okay, but if we need to define suppose concrete 3500 psi, in that case suppose here we are interested to use concrete 3500 psi. In that case, at first we have to modify the value of modulus of elasticity. That means $57,000 root over 3500 psi. 3372165. 3372165.476. 3372165.476. 3372165.476. Now go to design property data, then go to modify / show material property. Here you can write 3500, but this is very important. Design properties for concrete materials. Here we have to provide 3500 psi. That means if we are interested to define concrete strength as per our requirement, in that case we have to modify modulus of elasticity and design properties for concrete materials. Now click on OK. Add new material, rebar. Here we can use grade 60 or grade 75. Here I am interested to use grade 60. Okay, let's use grade 75. In Bangladesh, here we do not have river grade 75. Here available river grade is 500 W or 72.5 grade, we can say. So in that case, what we have to modify, let's discuss it. River 72.5. But note that for seismic design category D, generally we do not use this higher river grade. Okay, for seismic design category D, generally we use river 60 grade. But for our information, here we are discussing this issue. In that case, at first let's find out the, suppose here we are interested to use the grade 72.5, minimum yield strength Fy, maximum tensile strength Fu, expected yield strength Fye, expected tensile strength Fue. Let's check the ratio between these minimum yield strength and maximum tensile strength. Okay. Here the ratio will be maybe 1.33. Okay. Let's write down. For the ratio is 1.33. Then the ratio between this Fy and Fye is 82500 divided by 75000, maybe 1.11. Okay, 1.1. Similarly, the ratio between Fu and Fue is also 1.1. 1.1. Now, here we will write 72500 as our river is 72.5 grade or 72,500 psi. Now, what will be the value of Fu? It will be 72500 into 1.33. That is 96425. 96425. Now find out the value of expected yield strength, which will be 72500 into 1.1 equals 79750. 79750. Then 96425 multiplied by 1.1, that means the value will be 106067. 106067. So let me check the ratios of 96425 divided by, that means the ratio is 1.33 between Fy and Fu. Similarly, 79750 divided by 72500, 1.1, 10607, sorry, 10607 divided by 72500. Yeah, there is a mistake. Sorry, not that. 10607 divided by 96425. It's okay. 1.1. Now click on OK. Click on OK. That means if you are interested to modify the data as per your requirement, you can follow the previous procedure. Now we have to define section properties for column, beam, slab, stair, shear wall, etc. Let's go to define section properties, frame section. From here select delete multiple properties, select them all and delete them. From here, select all the properties except one. You can't delete all the properties at a time. You have to keep one properties at least. Now click on delete selected frame section. Click on OK. Go to add new property. Here section shape is concrete rectangular for our columns and beams. So let's go to concrete rectangular. Here I will write C1. Here we have to specify the column section. Initially here we are considering 12 inches by 20 inches. All the columns are 12 inches by 20 inches, except maybe there may have some variations. Okay, this one is 12 by 30 inches. This one is also 12 by 30 inches. Okay. That means initially in the architectural plan we have three sizes of column actually. Okay, this one is 12 by 25. Okay, we will define these three properties. C1 12 by 20. From here we will select concrete 3000 psi. For width input the value 12 inches. For depth input the value 20 inches. Width 12 inches. Depth 20 inches. Now go to property modifiers. Moment of inertia about axis 2 will be 0.7 for column, and moment of inertia about axis 3 will be also 0.7. Here we are considering the crack section analysis of frames. Okay, that means concrete will not carry any tensile stress, as concrete is weak in tension. Okay, that means we are considering the cracked section of the concrete frame or column, you can say. Click on OK. Now go to reinforcement. From here PM2, M3 design column is OK. Rebar material, here we are interested to use rebar 72.5. Again I am mentioning that for seismic design category D, generally we do not use rebar 72.5 or 75 grade. Okay, in our country here for seismic design category D, we use rebar 60 grade. Now, no need to change anything from here except rebar material. Now click on OK. Click on OK. Now we can delete this property, this unnecessary property actually, delete property. Now we will take copy of the previous property. So click on add copy of property. C2 equals 12 by 25. You can see as we have taken the copy of previous property, so we don't have to provide the value of material as C3500 psi manually. It is already selected by the software. Now from here we have to input the value of width. No need to change as it is already also 12 inches. But for depth we have to input the value of 25 inches. No need to change property modifiers as we have taken the copy of the previous section. No need to change here also. So this is the benefit of taking copy of previous property. Now go to add copy of property. C3 equals 12 by 30. Just input here 30 inches. No need to change anything. Add copy of property. Here we will also take C4 as 15 by 25. 15. Okay, initially we can take 15 by 20. 15 by 20. 15 by 20. We currently we don't know as it is necessary or not, but we are taking properties as much as possible. Okay, for the trial. 15 by 20 inches. Click on OK. Add copy of property. C5 maybe. C5 equals 15 by 25. 15 by 25. Click on OK. Add copy of properties. C6 equals 15 by 30. 15 by 30. Click on OK. Just save the file. Now we have to define properties for beam. So again, go to define section property, frame section. Go to add new property. Click on concrete rectangular section. B1. Here we will use 12 by 18 inches. Material select concrete 3500 psi. For width, input the value 12 inches. For depth, input the value 15 inches. Sorry, 18 inches actually. Now go to property modifiers. For beam, we will use moment of inertia about 2 axis 0.35 and about 3 axis also 0.35. That means we are again we are considering the cracked section of concrete beam. That means if you are interested to consider the cracked section of concrete column, in that case you have to assign 0.7 for column, and for beam if you are interested to for crack section analysis, in that case you have to assign 0.35 for beam. Reinforcement, from here select M3 beam design, just select revert 72.5, click on OK. Click on OK. Take copy of this property, add copy of property. B2 equals 12 by 21. From here just select 21, no need to change here, also no need to change, as we have taken the copy of property B1. Now again take copy of B2, name it as B3 equals 12 by 24, just input here 24 inches, click on OK. Now click on OK. Save the file. Now we have to define properties for slab. So go to define section property, slab section. Here we can delete this property. Go to add new property, slab 6 inches. From here I will select concrete 3500 psi. Here you can see in modeling type there have shell thin, shell thick and membrane. The basic difference between membrane and shell is membrane can't resist any forces or moment, but shell can resist forces or moments. This is the basic difference. Suppose a page of your book or notebook can be considered as a membrane, as it can't resist any forces or moments. Okay, it will be bended if forces are applied. But shell can resist some amount of forces and moments. Now, what is the difference between shell thin and shell thick? Okay. At first we will go for slab 6 inches one way. For one-way slab, we will take membrane. Later we will discuss the differences between shell thin and shell thick. Okay. For one-way slab, that means we are considering modeling type as membrane. Now select use a special one-way load distribution. From here choose slab thickness as 6 inches. Now, important thing is you can't consider the slab thickness randomly. For taking the decision about slab thickness, you can follow this chart. Minimum thickness of one-way slab for simply supported. Here you can see for simply supported slab, minimum thickness should be L by 20, one and continuous, L by 24, both and continuous, L by 28 for cantilevered slab, L by 10. Here we have also a note. Minimum thickness of solid two-way slab should be perimeter divided by 180. So take decision from this chart. Here I have already checked 6 inch thickness is enough for this structure. Later we can reduce the thickness also while we are designing slab. but this is not important here. Here we can complete our analysis by considering the slab thickness as 6 inches. Okay. Now click on OK. Then we can delete this property, add new property, slab 6 inches, slab 6 inches, two-way. Slab material should be 3500. Here now we will take shell thin. Why shell thin? If you go to CSI America, shell thin versus shell thick, CSI America. Here you can see the basic differences between shell thin and shell thick. We should consider shell thick when shell thickness is greater than approximately 1/5 to 1/10 times of the span. If the thickness of our shell is greater than approximately 1/5 to 1/10 times of the span, in that case we will consider shell thick. Otherwise we can go with shell thin. So I have already checked that for this structure shell thin is okay. Now from here select thickness 6 inches, slab 6 inches, two-way slab material, shell thin, okay. Now we can take copy of slab 6 inches one way, add copy of property, name it as landing slab, landing slab. Here we are interested to use the thickness of landing slab 6 inches, so click on OK. Take copy, add copy of property, waist slab, waist slab. We will consider this one as 9 inches because in ETABS we can't model a riser. So here we are considering a average thickness of 9 inches for staircase. Okay. Now if you have a lift machine room or water tank, in that case you can consider more properties. Suppose here I am interested to use new property, no, add copy of property, name it as water tank, bottom slab 8 inches. So from here select 8 inches. Okay, we are considering this one as one way. Later if we find it that the slab, okay, let's check. Here we have a water tank in this position of staircase. It will be automatically one way actually. Let's check. 7 feet 6, 15 feet. This is one way. So from here I am selecting water tank bottom slab 8 inches, 3500 membrane, thickness 8 inches. Okay. That means we have also defined properties for slab. In this structure we do not have any shear wall, so we will not define any shear wall here. But if you have any shear wall, you can define shear wall also. Let me show you. Suppose go to define section property, wall sections, add new property. Now from here suppose I am writing shear wall 12 inches. From here we will select this one. Similar definition for shear wall also, the difference between for the differences between shell thin and shell thick, as we have discussed earlier. Go to modifiers. From here for all the periods use 0.7 for F11, F22, F12. M12. Okay, first 6 values. From where we are using these values, Go to website again, search crack section, modeling, CSI America. Here you can see for beam it is 0.35, for column it is 0.70. Walls uncracked, this value is 0.70. F11, F22, here it is written that M11, M22, M12 is also 0.70. If you go here, you will see that there is no recommendations about reducing the GA share. You should, however, note that some of our users use modifiers for F12 also, where they expect deterioration of shear stiffness and want to be realistic in their modeling. That means for F11, F22 and F12, we have to use values for 0.70 if we are interested to model uncracked wall. If we are interested to use cracked wall, in that case we have to use 0.35 for F11, F22, F12, M11, M22 and M12. But wall shear wall is a big thing. For shear walls, generally we do not consider cracked section. Okay, generally. Okay, again I am telling, if you are interested to use the cracked section, in that case here you can use 0.35. Okay, click on OK. Shear wall 12 inches, click on OK. Delete this one. Add copy of add new property. Suppose here if you are interested to define a spandrel, suppose spandrel 12 inches, in that case we will use here 0.35. That means for spandrel beam we are considering cracked section, but for the pier we are not considering the cracked section. Again I am telling, you can consider all the shear walls as cracked and all the shear walls as uncracked, or you can do like what am I doing. Okay, what I am doing now. We have already defined a spandrel and spandrel and pier. That means today we have completed up to step number 4. In the next tutorial we will start from step number 5. That's all for today. See you in the next tutorial. Thank you.